Why is Python slow? If you have ever written Python code, you have probably heard this. Python can run 10 to 100 times slower than languages like C or Java. But here is the question nobody asks. If this is such a well-known problem, why has not it been fixed? Today I am going to explain the real technical reason Python is slow and why changing it is not as simple as you think. Let's start with just how slow we are talking about. A simple loop that adds numbers takes Python about 1 second, the exact same code in C about 10 milliseconds. That's 100 times faster. But here is what's interesting. Despite being slow, Python is one of the most popular languages in the world. YouTube, Instagram, Spotify, all built with Python. So clearly the speed issue is not stopping anyone. But why does it exist in the first place? To understand this, we need to go back to 1991. A programmer named Guido van Rossum was working on a project during his Christmas break. He wanted to create a language that was easy to read, easy to write, and fun to use. Speed was not the priority, simplicity was. And this decision shaped everything about Python. Python is an interpreted language. That means when you run Python code, it doesn't get converted into machine code ahead of time. Instead, Python reads your code line by line and translates it on the fly. Compare that to a compiled languages like C. C code gets converted into machine code once before you even run it. So when you execute a C program, the computer is reading pure machine instructions. No translation needed. Python, on the other hand, is constantly translating while your program runs, and translation takes time. But there is another reason Python is slow, and this one is more controversial. It's called GIL, the Global Interpreter Lock. Here is what it does. In most programming languages, you can run multiple threads at the same time. This is called parallel processing. But in Python, the GIL prevents this. Only one thread can execute Python code at a time. Even if your computer has 8 cores, Python can only use one core for Python code. So why does the GIL exist? It was added to make a memory management simpler. In Python, the interpreter needs to keep track of how many references exist to each object. Without the GIL, multiple threads could mess with that count at the same time and cause crashes or memory leaks. The GIL prevents that by forcing threads to make turns safe yes, fast no. So, if the GIL and the interpreter make Python slow, why has not anyone just removed them? The answer is they have tried. In the early 2000s, developers tried to remove the GIL. The result, single-threaded Python code became even slower, and most Python code is single-threaded. So the change made things worse for most users. It was rolled back. Here is the reality. Python was designed to be simple, readable, and beginner-friendly. Speed was sacrificed for ease of use. And most use cases, that's the right trade-off. Data science, scripting, web backends, Python is fast enough. And when it's not, developers use C extensions or tools like NumPy that bypass Python's slowness. But there is some good news. In 2023, Python's core developers announced something big, a project to make Python 3.13 optionally GIL free. This won't make Python as fast as C, but it could make multi-threaded Python code significantly faster. It's still experimental, but it's a start. So to sum it up, Python is slow because it's interpreted, not compiled, and because the GIL limits parallel processing. These design choices were intentional. They prioritized simplicity over speed, and for millions of developers, that was the right call. Python speed is a feature, not a bug. It made programming accessible. That's why Python is slow and why it might not matter as much as you think. If you found this helpful, subscribe for more videos like this. Next time we will talk about why JavaScript has double equals and triple equals. Thanks for watching.